Okay, hello everyone. This is our ANW project. We chose to combine written text together with visual and audio aid to make our presentation clearer. As for our test itself, we're going to analyze the chemical reaction between Coke and Mentos.
To accompany the explanation, we decided to perform 3 tests: mixing Coke with Mentos, carbonated water with Mentos, and Coke with another substance. The results of these tests will then provide an answer to the question how this reaction takes place. The basic reaction: Coke and Mentos mix together, creating a large tower of foam that is shot out of the bottle. We expect this reaction to take place because of the carbon dioxide inside of the Coke mixing with the Mentos.
Okay, so today we're gonna drop Mentos in Coke and Spa, and let's see what happens. Anything to add? Okay, so this is our first test. These are the optimum conditions. We're gonna put Mentos in Coke Light, and it should give us a big fight. So let's start. Okay, so first test, 10 Mentos in 1 liter Coke Light.
As you just saw, mixing Coke and Mentos has a rather explosive result. The foam spurting out of the bottle is a chain reaction. The large, dimply surface area of the Mentos encourages bubble growth of the carbon dioxide inside of the Coke, by disrupting the connection between water molecules. This lowers the surface tension of the Coke, giving way to even more bubble growth. In the test, as soon as we dropped the Mentos into the Coke and it started sinking to the bottom, bubbles began to form against the Mentos, pushing the liquid above them up and out of the bottle.
Well, let's look at some Mentos close up. If we zoom in, we can see this, which is the rough surface area we were talking about. And this is how Coke behaves around the surface of the Mentos. And this is where the gas bubbles are formed. As you can see, the, let's call them dents, are very deep, and there are lots of them, so lots of gas can gather. So if that's the only thing to it, then carbonated water should work just as fine, right? The Mentos goes into the carbonated water, the gas gathers in the craters, and it rises to the surface, right? Well, let's see what happens.
10 Mentos and 1 liter Spa.
So as you can see, we didn't get the same explosive result as we got with the Diet Coke. This is because of a chemical sweetener called aspartame. What this does is it decreases the surface tension, making it easier for bubbles to go out of the liquid and rise to the surface. Without this chemical, gas is still released, but it just takes much longer. So let's look at the Mentos again. When we mixed Coke and Mentos, the aspartame worked in such a way that the dimples were very deep. However, Spa doesn't have this aspartame, which in turn makes the surface tension higher and causes less bubbles to form. With the Diet Coke, it bubbled intensely but for a short period of time. With our carbonated water, it bubbled slightly but for a very long time. So for the following experiment, we're going to mix Coke with something that everyone will agree is rough: sand. Let's see if we get just as many bubbles. Sand and Coke. 3, 2, 1. Oh, fuck. So yeah, it doesn't work the same. So as you can see, we didn't get quite the same result. But how can it be that Mentos causes more bubbles while sand looks rougher? Well, to answer that question, we have to look at Mentos and sand microscopically. So if we were to zoom in on a sand grain, this is what we would see. Since we're already familiar with how the liquid behaves around the surface area, we're only gonna look at where gas bubbles form. So as you can see, there's a reasonable amount of dents. But if we compare it to the Mentos, you can clearly see the difference. Despite the fact that there are more grains of sand than Mentos, it does not even out. As you can see, there are many more places on the Mentos where gas can form. This is just a random ratio, but it's just to give you an idea. Thank you for watching the video, and we hope that we've explained it in a clear and understandable manner. Now you can explain to your friends how the fountain of Coke works.